Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on December 12, 2025, about 5 days ago. It introduces MetaCanvas, a lightweight interface that lets powerful multimodal large language models directly plan in the hidden space of diffusion models. And in tests, it reaches about 0.86 on the general eval benchmark, compared with about 0.84 for strong text-only baselines. The paper is titled, Exploring MLLM Diffusion Information Transfer with MetaCanvas. And as we will see later, the results are really promising for more precise and controllable image and video generation. Alright, the previous segment introduced the core idea. Figure 1 now shows how the whole MetaCanvas pipeline connects together. The left side encodes any input image or video with a variational autoencoder, turning pixels into compact latent features. The center block shows the frozen multimodal large language model, which reads text and media instructions and also controls the learnable two-dimensional or three-dimensional canvas tokens. The right side then feeds both the latents and the refined canvas embeddings into the diffusion transformer, so the generator receives patch-level spatial or temporal plans instead of only a single global text condition. Well, Figure 2 zooms into the connector that sits between the multimodal large language model and the diffusion transformer. The left vanilla transformer block reshapes the canvas token embeddings so they align with the diffusion latent space. The right diffusion transformer block then mixes these transformed canvas features with the noisy latents using adaptive layer normalization so the planner can steer each patch. 0 initialized linear layers ensure the connector starts out harmless and only gradually learns to influence generation. Alright, the previous figure unpacked the connector blocks in detail, and Table 3 now shows which of those pieces actually matter for general eval performance. The full MetaCanvas design reaches about 68, clearly above the baseline around 64. Removing time-step conditioning, the diffusion transformer block, or the vanilla transformer block, each knocks performance down by around 0.6 to 1 point. Adding canvas tokens before patchification hurts even more, which confirms that late fusion in latent space is crucial. So, while the previous table focused on connector ablations, Table 1 compares image editing quality across many systems on the IMG edit benchmark. The shaded bottom row shows Flux 1 context dev with MetaCanvas, which improves over plain Flux 1 context dev in every editing type. Gains are modest for simple add or adjust edits, but they grow larger for harder categories like remove, hybrid, and action edits. The final overall score rises from about 3.5 to about 3.9, putting this approach near the top of the open models. So, after seeing image editing gains, Table 5 turns to video editing and compares many systems across automatic scores and human preference. The top block lists text encoder-based editors, which reach decent quality but only moderate edit accuracy and user preference. The lower block highlights the multimodal large language model setup. Without canvas tokens, the baseline already scores strongly, yet adding canvas tokens boosts the semantics, edit accuracy, consistency, and overall human preference to the best values in the table. Alright, after the broader video editing comparison, Table 4 zooms in on the image-to-video benchmark versus bench I2 versus. The table reports 3 metrics: an I2 versus score, a quality score, and an overall score that combines them. Traditional text encoder models like Cog Video X and Hanyuan Video post strong numbers, but their overall scores stay around 87. One 2.25B plus MetaCanvas reaches the best I2 versus score of about 98, and the top overall score around 87.1, while keeping competitive quality so planning in latent space does not sacrifice base generation strength. Okay, after the broader image and video results, Table 8 isolates performance on the general eval compositional benchmark. The upper block lists diffusion transformers without multimodal language models, which reach scores around 0.66 to 0.82. The middle block shows query-based planners, which climb to about 0.84. The final highlighted row reports MetaCanvas at 0.86, so spatial canvas planning gives a clear but efficient boost over both families. MetaCanvas shows that treating multimodal large language models as latent space planners via canvas tokens in a tiny connector can reliably boost compositional control in both images and videos without heavy extra compute. The broader implication is that future visual generators may act less like black boxes and more like controllable collaborators. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.